Assalamualaikum warahmatullahi wabarakatuh. Saya Aziz Zulkifli yang mengerti 2026. Kami dari Grup 6, Seksyen 5, Computer Edit Design Laboratory. Hari ini saya dan rakan-rakan saya ingin membentangkan tentang projek yang telah kami hasilkan, iaitu adalah Soul Motion Sensor. Ini adalah kumpulan saya, iaitu saya, Aziz Zulkifli, A25106, Muhammad Samsul Azharuddin bin Muhammad Azhar, A25034, dan Muhammad Darul Selesa Rizan di A21587 dan Muhammad Arif bin Muhammad Faidus di A250. So introduction, soil moisture plays an important role in agriculture and plant growth, as it determines how much water is available for crops. In modern farming and gardening systems, it is important to monitor soil condition accurately to avoid overwatering or underwatering plants. The project focused on designing and developing a soil moisture sensor system using basic electronic components and CAD simulation tools. Next, this is our circuit schematic. Uh, Automated soil moisture monitoring system controlled by an Arduino Uno. Theoretically and functionally, the soil moisture sensor S1 acts as a resistive transducer that converts physical soil conductivity into a proportional analog voltage 0 to 5. Send to analog pin to a 0 where it converts into a digital value 0 till 1033 to determine the soil hydration level. Depending on this available data, the Arduino drives its digital output pins to provide time alert. It selectively pull pins D2, D3 or D4, load to complete circuit and illumination specific such as LED, D1, D2 or D3 to current limiting 222 ohms reduction. Resistor to inductor, dry, optimal, or wet state. For the simulation and analysis, volumetric water content is low, and this is the volumetric water content in the soil is high. When volume water in the soil is low, it will trigger the buzzer and then it will automatically it will inform the user of low volume water in the soil. If volume soil surpass the level 750 out of 876 based on the recording, the buzzer will stop giving signal and red LED will turn off. AA251518. So my task is create a PCB. So this is my in this way you can how I create our PCB. So this circuit is operate using a 5 voltage power supply in a common ground connection where the microcontroller connect to the GP1, GP2. So connected to the GP1 and GP2 where the pin controls the operation of LED1 and LED2 as output indicator. So I uh, I take the 220 ohm resistor for my resist1 resistor. I use to limit the current flowing to the LED recorded them again. Why is in one switch serve can hit device the toggle and the microcontroller to detect user activity. So when the microcontroller send the high signal to the corresponding output pins, current flows through the resistor and LED to the ground, causing the LED to illuminate. So other than that, therefore, the circuit function as a simple input-output system that demonstrates the interaction between a switch input and LED output indicators. So the next one is my schematic PCB. So for the PCB layout, so the shown in this image, it's designed to connect the SG1 buzzer LED2 indicator and a header connector, which is JP2 and JP3. To proper space that provide electrical pathway between the components. So this PCB layout ensure power and signal connection are essentially from the header pins to the buzzer and LED. So the system allowing to produce both visual and audible when electric. So the focus trace routing external placement has minimized connection secret reliability. So this stable operation of electric station. So that's all from my side. So thank you. Hello everyone. Today I'm gonna explain about skateboard design by Richard. Because system and Arduino Uno based microcontroller circuit likely designed for smart offline monitoring. Think import soil moisture sensor connected to VGA SIG ground pin to monitor soil dryness. Two output, a buzzer for audio alert and two LEDs, LED1 and LED2, with current limiting resistors L1 and L2 for visual status inductors. For the layout and routing, use horizontal skateboard track and orange line and jumper wires with a green line. To cleanly route 5 volt and ground, also signal line. That's all from me. Thank you. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Samsul Azharuddin. So in this slide, it is present the 3D casing design for the soil moisture monitoring system. The casing was designed using TinkerCAD 3D design software to protect the electronic component and provide a neat and professional appearance. The enclosure also improves safety by preventing direct contact with the circuit and keeping the wiring organized. So the main design feature include a compartment for the Arduino Uno, for the soil moisture sensor, LED indicator openings, the buzzer sound outlet, and a USB access port for programming and power supply. The overall dimension of the casing are 180 millimeters in length, 120 millimeters in width, and 40 millimeters in height. This dimension provides sufficient space for all compartments while maintaining a compact design. In terms of wiring arrangement, the soil moisture sensor is connected to the Arduino through analog pin 10. The green LED indicates that the soil is dry and required watering, while the red LED indicates that the soil contains sufficient moisture. The buzzer is activated when the soil moisture level is low to alert the user. All components are powered directly through the Arduino and share a common 5-volt power supply and ground connection. Overall, this casing design provides a durable, user-friendly, and presentable enclosure for the complete soil moisture monitoring system. That's all from us. Thank you.